exponents. If I take a squared, that's just short for a times a, right? And a to the third means a times a times a. And in general, a to the n means a times dot 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 times a, and it just means n factors, and that's n any counting number. That's how exponentials are introduced in about 6th grade, exponential notation. And so we all agree what that means then, right? We know what it means in the case of natural numbers. Rules of exponents come from just figuring out what works for the natural numbers, for the exponent, and then saying that's going to be what the rule always is. We're going to say that whatever works for the natural numbers works for all numbers. So we know that a squared times a to the third, that's going to be a times a times a times a times a. That's 2 copies of a plus 3 copies of a. So we have this rule that tells me that the way I compute the product of 2 exponentials is to add the exponents, if the base a is the same. And so that's going to give me a rule. A to the x times a to the y will equal a to the x plus y for all x and y. We figure out what works for whole numbers, and we declare that to be what works for everything. If we look at a squared to the third, that's just going to mean a times a, one group of 2, another group of 2, and another group of 2. This is one of the first models of multiplication you ever saw in elementary school, the repeated addition model of multiplication. When you first define multiplication, it's a shorthand for writing out what you mean by adding the same number to itself a whole bunch of times. So this is a to the 2 times 3, which is a to the 6. If we do it in the other order, we get 3 copies and another 3 copies. So what you have here is 2 groups of 3. So this is a to the 3 times 2, and since 2 times 3 and 3 times 2 are the same, you get a to the 6, and you get another rule, which says that for all x and y, if we take a to the x to the y, we're going to get a to the product power, x times y. Everything you know about exponents follows from those 2 ideas. It's what has to happen. So all the other rules that you might have at one time thought, wow, that's a lot to memorize, it's really just what it has to be. For instance, if we look at what should a to the 0 be? Well, a to the 0 times a squared by this rule should be a to the 0 plus 2, which is a squared. So this thing fills in the box what times the number a squared gives me the number a squared. So if I just gave you the second equation and said what number has to go in that box, what would it be? It has to be 1. So we get the sort of derived rule that anything the 0 power equals 1. Let's see. So now if we look at what a to the minus n should do, well, if we multiply that by a to the n, that's going to be a to the 0, which we just figured out is 1. But if I ask you what times a to the n equals 1, you divide it through by a to the n. And so we get another rule. But this one's a derived rule that says that a to the negative n power is the same thing as 1 over a to the n. Not because somebody just decided it would be that, but because if we're going to declare these 2 rules, it has to be that. If we take a to the 1 over n, what should happen with a fractional exponent? Because what's going to happen is if we raise that to the nth power by our second rule here, we have to multiply the powers. That's a to the 1 over n times n, which is just a to the 1, which is a. And so here I have something whose nth power is equal to a. This is the nth root of a. That's actually how you define the idea of a cube root or a 10th root or whatever. And so that implies this rule that a to the 1 over n is the same thing as the nth root of the number a. Too many people come out of high school thinking that these rules are just these arbitrary things that they have to memorize how things work. And no, they're not. If you go back to the very first stuff you ever did with exponents, just what the exponent notation means, you derive two rules that are what they have to be if they're going to work with whole numbers. You just say those are going to be the rules, and all the other stuff about exponents falls right out. It is what it has to be. You don't have any choice about how to define what the 0 power means or what the negative 2/3 power means. It's forced from the very basic rules of how whole number exponents work